Okay, so this video is going to talk about forces at an angle. And the first one that I want to talk about is pulling a wagon. So pulling a wagon is when an applied force is applied to an object with an upwards force. So upwards and to the right force. So here is our object. And anytime you pull a wagon, you have a handle, and that handle is pulling up and to either the right or the left. So we still have our normal four forces. We still have our force of weight that is down, and that's mass times gravity. And then we also still have our frictional force, which is working in the opposite direction. And then we also still have our normal force, which is the surface pressing up. But at this point, our force applied is at an angle to the horizontal. So because it's at an angle, we need to break it into its two components. So the components are the vertical component and the horizontal component. Now, this is just simple trig, because what happens is when I have a vertical component and a horizontal component, my resultant is the hypotenuse of the triangle. So for my vertical component, which I deem as the force applied in the y direction, or the phi, that's equal to the sine of theta times the force applied. And then for the horizontal direction, which I lovingly call the fax, or the force applied in the x direction, that's equal to the cosine of theta times the force applied. So now that we've determined what our forces are in the linear fashion, so vertical and horizontal, now we can do our sum of forces formulas. So always and forever we have our sum of forces, which is equal to mass times acceleration. And then we have our sum of forces in the parallel direction, and that's equal to our force applied in the x direction minus our force of friction. And then we also have our sum of forces in the perpendicular direction, and this one's a little bit trickier, but because your normal force and your force applied in the y are in the same direction, then those are going to add together. So I'm going to have my force of weight, and that's going to subtract the normal force and the force applied in the y. So this should equal to 0, but the reason that your normal force is adding to your phi is that when I apply a force upward, I'm lifting it kind of off the ground. So the force of weight is still going to be the force of weight, but my normal force is going to be less because of this additional force being added in the same direction.